National Electrical Code, or NEC, Section 250.30, states that where the disconnect for a building or structure is not readily accessible from outside or inside the building, a remote disconnect shall be provided. NEC Section 250.32 B1 says that for buildings or structures that are not attached to the service equipment enclosure, the switch shall be installed within sight of the building or structure or be capable of being locked in the open position. Considering these code sections, let's talk about a situation involving providing a 100 amps branch circuit feeder to a new detached building located 20 feet from a dwelling unit. The detached building is 20 feet by 30 feet with metal sides and a metal roof, one walk-in door and a two-car garage door, and a dirt floor. The question revolves around the proper disconnect location at the detached building. The detached building is not attached to the service equipment enclosure. Therefore, a disconnect is required to be installed in the detached building that is either within sight of the building, which would mean a disconnect mounted on the exterior of the detached building facing the dwelling, or capable of being locked in the open position. This allows for a disconnect to be installed inside the detached building, as long as there is a provision for locking it in the open position for safety. Based on the code requirements, it is recommended to install a disconnect to the detached building, either on the exterior or interior, to meet the requirements of 250.32. B1. A main Lagoni panel with an equipment grounding lead would not meet these requirements. Since the detached building is not attached to the dwelling, separate grounding electrodes and grounding conductors are required. The supply conductors to the detached building may need to be protected from physical damage, such as by using conduit or underground burial. When installing a disconnect at a detached building, firstly, determine the load requirements of the building. This will help you select the appropriate size disconnect switch. Secondly, choose a location for the disconnect switch that meets the NEC requirements. If the disconnect switch is not within sight of the main building, it must be capable of being locked in the open position. Thirdly, install the disconnect switch according to the manufacturer's instructions. Be sure to use the correct size conductors and connectors. Fourthly, ground the disconnect switch according to the NEC requirements. This will help protect against electrical shock. Fifthly, test the disconnect switch to make sure it is working properly. This will help ensure the safety of the electrical system. The purpose of a disconnect switch is to provide a means of disconnecting power to a building or structure in the event of an emergency or for maintenance purposes. It is an important safety device that can help prevent electrical shock and fires. Here's an expanded look at disconnects, covering various aspects and considerations. Firstly, NEC requirements provide the specific rules and guidelines for disconnects. These requirements vary depending on the application and the voltage level. Consulting the latest edition of the NEC is crucial for compliance. Secondly, types of disconnects include fuse disconnects, which incorporate fuses to provide overcurrent protection in addition to disconnecting means. Non-fuse disconnects provide only the disconnecting function, and a separate overcurrent protection device, such as a circuit breaker, is required upstream. Manual disconnects are operated by hand, typically with a handle or switch. Automatic disconnects are triggered by a sensor or control system, often used in emergency shutdown systems. Thirdly, location considerations play an important role. Readily accessible disconnects should be easily reachable without obstacles or the need to climb or remove barriers. Within-site disconnects must be visible from the equipment they serve, typically within 50 feet, to ensure the operator can verify the equipment is energized before working on it. Remote disconnects are used when the disconnect is not within sight or readily accessible. These may require additional safety measures like lockout-tagout procedures. Fourthly, sizing and selection are determined by the load requirements of the equipment or circuit it serves. The disconnect must have an amperage rating equal to or greater than the calculated load. The voltage rating must also be appropriate for the system voltage. Fifthly, installation best practices require that disconnects must be installed according to the manufacturer's instructions and local electrical codes. Proper grounding and bonding are essential for safety and to prevent electrical shock. Enclosures should be suitable for the environment, such as weather-resistant enclosures for outdoor installations. Sixthly, safety features are crucial. Lockout-tagout mechanisms allow the disconnect to be locked in the open position during maintenance or repair to prevent accidental energization. Clear labeling indicates the function and purpose of the disconnect, as well as the equipment it serves. Protective barriers or covers can prevent accidental contact with live parts. Seventhly, maintenance and testing are necessary. Regular inspection should check for any signs of damage, corrosion, or loose connections. Operational testing verifies that the disconnect functions properly and can interrupt the circuit under load. Infrared scanning can detect hotspots or overheating, indicating potential problems. Eighthly, specific applications of disconnects are wide-ranging. HVAC systems often require disconnects located near the outdoor unit for servicing. Motors typically have disconnects located within sight of the motor or at the motor control center. Industrial equipment may have multiple disconnects for different sections or functions of the machinery. Emergency systems such as backup generators and fire pumps require reliable disconnects to isolate them from the main power supply. Ninthly, grounding and bonding of a disconnect involves connecting the metal enclosure of the disconnect to the grounding system to provide a path for fault current. Bonding ensures that all metal parts are at the same potential to minimize the risk of electric shock. The size of the grounding and bonding conductors must comply with NEC tables 250.122 and 250.66, respectively. Tenthly, overcurrent protection must be considered. Fuse disconnects provide overcurrent protection with fuses rated to protect the circuit and equipment. Non-fused disconnects require a separate overcurrent protection device, such as a circuit breaker, installed upstream. The overcurrent protection device must be sized according to the ampacity of the conductors and the requirements of the equipment being served. 11thly, environmental considerations must be taken into account. NEMA-rated enclosures protect the disconnect from environmental factors such as moisture, dust, and corrosion. Weatherproof enclosures are required for outdoor installations to prevent water ingress. Hazardous location disconnects are designed for use in areas where flammable gases or vapors may be present. 12thly, arc flash hazard mitigation requires the use of arc-rated disconnects, which are designed to withstand the effects of an arc flash. Remote operation can allow the disconnect to be operated from a safe distance, reducing the risk of injury. Proper personal protective equipment, or PPE, should be worn when operating disconnects in potentially hazardous areas. 13thly, voltage drop considerations can influence the selection of conductor size for the circuit feeding the disconnect. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. 14thly, conductor ampacity must be matched to the rating of the disconnect and the overcurrent protection device. The ampacity of the conductors must be equal to or greater than the load they are intended to carry. NEC Table 310.16 provides ampacity ratings for various types of conductors based on their insulation and temperature rating. 15thly, labeling requirements include clear and legible labels that identify the equipment served by the disconnect. Labels should indicate the voltage, amperage, and phase of the circuit. Warning labels should be used to alert personnel to potential hazards. 16thly, coordination with other electrical equipment is essential. Disconnect should be coordinated with upstream and downstream devices to ensure proper operation and protection. Selective coordination ensures that only the closest overcurrent protection device trips in the event of a fault, minimizing disruption to the rest of the electrical system. 17thly, regulatory compliance extends beyond the NEC. Local electrical codes and regulations may have additional requirements for disconnects. Compliance with industry standards such as those from Underwriters Laboratories, or ALL, and the Institute of Electrical and Electronics Engineers, or IEE, may also be required. 18thly, troubleshooting disconnects can involve several steps. Check for proper voltage at the disconnect to ensure that power is being supplied. Inspect the disconnect for any signs of damage, such as broken parts or burned contacts. Test the continuity of the circuit to identify any open circuits or shorts. 19thly, future trends in disconnect technology include the development of smart disconnects that can be remotely monitored and controlled. Improved arc flash protection technologies are being developed to enhance safety. Wireless communication capabilities allow disconnects to be integrated into building automation systems. 20thly, case studies of successful disconnect installations can offer valuable lessons. Analyze installations in different types of facilities, such as industrial plants, commercial buildings, and residential complexes. Identify best practices and common mistakes to avoid. 21stly, the economic impact of proper disconnect selection and installation should be considered. Reduce downtime due to equipment failure. Lower maintenance costs. Improved energy efficiency. 22ndly, the importance of training and certification for electricians and technicians who install and maintain disconnects is crucial. Proper training ensures that personnel are familiar with the NEC requirements and best practices. Certification demonstrates competence and professionalism. 23rdly, documentation and record keeping for disconnect installations are essential. Maintain accurate records of disconnect locations, ratings, and wiring diagrams. Keep records of inspections, testing, and maintenance activities. 24thly, public awareness campaigns can educate the public about the importance of disconnects and electrical safety. Promote the use of qualified electricians for electrical work. Provide information on how to identify and report electrical hazards. 25thly, ethical considerations for electrical contractors and engineers should be taken into account. Always prioritize safety over cost. Adhere to the highest standards of professionalism and integrity. Provide honest and transparent advice to clients.